We'll be learning about global Anycast versus regional load balancing. I'm Chris, cloud architect and founder of systemsarchitect.io and codeguides.io. Subscribe to the channel and like this video. What if one of your regions drops out and your DNS says everything is fine for the next 4 minutes? Nobody honors a 60-second TTL. Meanwhile, a customer in Frankfurt gets served from Virginia. Now you are explaining to a regulator why personal data crossed an ocean you said it never would. Both failures come from one unanswered question. Who decides which region gets a request? You have two answers available. The network can decide for you at the IP layer through BGP, or you decide yourself at the DNS layer with routing policies you write down. By the way, BGP is Border Gateway Protocol. It lets internet systems exchange routing information with each other. Let the network decide when every region runs the same stack and holds replicated data. You get nearest endpoint routing, failover in seconds, and attack traffic split across dozens of locations. Decide yourself when a specific region must handle specific traffic. Maybe the data lives there, or the law says so. I should mention, this presentation is a condensed version of the complete article on blog.systemsarchitect.io. View the full blog article with more details there. If every region is interchangeable, let the network route. If they are not interchangeable, write the routing rules yourself. Many mature architectures run both, with Anycast at the edge and explicit policies behind it. The two checklists ahead sort your traffic onto the right layer. Global Anycast with CloudFront, Cloudflare, and AWS Global Accelerator. Anycast announces the same IP address from many locations at once. The Internet's routing tables deliver each packet to the closest announcement. There is no lookup to get wrong and no record to cache. The decision happens per packet at the network layer. You also inherit the provider's global capacity, which is why Anycast absorbs volumetric attacks instead of folding under them. 4 or more of these makes a strong case for Anycast. 1. The application spans multiple global regions. 2. Automatic geographic routing is wanted. 3. DDoS resilience is a requirement. 4. You already run a CDN or edge network. 5. DNS resolution speed matters. 6. Any region can serve any user. 7. Simplified DNS is worth a lot. 8. Failover has to be automatic. 9. UDP-based services are core. 10. Nearest path routing drives revenue. 1. The application spans multiple global regions. Active deployments across North America, Europe, and Asia Pacific. Every region runs the full stack and can serve anybody who arrives. Adding capacity just means announcing the same address from another location. If you only run 1 or 2 regions, BGP has nothing to choose between. 2. Automatic geographic routing is wanted. DNS-based routing infers where a user is from where their resolver is. That quietly breaks for anyone behind a corporate resolver or a VPN. Anycast routes on real network topology instead. A user in Singapore reaches a Singapore point of presence, even if their lookup resolved through Oregon. 3. DDoS resilience is a requirement. What makes Anycast so hard to knock over? What makes Anycast address is announced from every location in the network. An attack aimed at it arrives split across all of them. A terabit scale flood that would saturate any single origin becomes a manageable fraction at each of several dozen points of presence. 4. You already run a CDN or edge network. CloudFront, Cloudflare, Fastly, and Akamai all run Anycast underneath. This is by far the cheapest path to Anycast. No autonomous system number, no BGP sessions, no transit provider. 5. DNS resolution speed matters. Anycast DNS answers from the nearest node in single-digit milliseconds. A distant single-region name server can take well over 100. That gap lands on the very first step of every cold connection. 6. Any region can serve any user. Stateless services on globally replicated stores can answer correctly from anywhere. Anycast assumes exactly that. because you do not control where a packet lands. Point it at sticky sessions and it will eventually send someone to the wrong place. 7. Simplified DNS is worth a lot. Your DNS collapses to one address that works everywhere. That removes a whole family of incidents, like the health check nobody re-enabled. 8. Failover has to be automatic. When a location goes down, its BGP announcement is withdrawn. The internet converges onto the next nearest one within seconds. Why is DNS failover so much slower? Clients, resolvers, and application runtimes all cache records for longer than the time to live claims. 9 UDP-based services are core. DNS, QUIC, voice over IP, and game traffic carry no connection state. Routing each packet to the nearest node costs nothing. TCP over Anycast needs more care. A route change mid-connection can reset the session. 10. Nearest path routing drives revenue. Real-time bidding, multiplayer, and live video are workloads where 10 milliseconds shows up in the numbers. BGP path cost tracks real network distance better than a geolocation database. When latency is the product, that difference is the whole game. Regional load balancing with Route 53, Azure Traffic Manager, and Cloud DNS. Regional load balancing keeps the decision in DNS. You express it as policy. Geolocation rules, weights, latency measurements, or explicit failover. Every response is something you configured on purpose. You can explain it, audit it, and change it. The cost is a caching layer between you and the client. The benefit is that no packet ever reaches a region you did not intend. Run through these 10 the same way, and if this list gathers more matches, keep the decision in DNS. 1. The application runs in one or few regions. 2. Explicit control over traffic is required. 3. Data residency obligations apply. 4. The second region is a warm standby. 5. Session affinity is required. 6. Databases are regional and unreplicated. 7. Weighted rollouts are part of the process. 8. Latency routing needs explicit health checks. 9. You are standardized on one cloud. 10. Fine-grained routing control is preferred. 1. The application runs in one or few regions. A primary in North America with maybe a secondary in Europe gives BGP almost nothing to choose from. DNS health checks handle failover across that small set perfectly well. Anycast starts paying off when manual policy becomes the bottleneck. 2-point explicit control over traffic is required. What does explicit control actually buy you? Sending enterprise accounts to dedicated infrastructure is a statement about intent, not network distance. DNS routing policies let you write those rules down and review them. 3. Data residency obligations apply. Several jurisdictions constrain where personal data may be processed or stored. Route 53, Azure Traffic Manager, and Cloud DNS geolocation policies guarantee a German user reaches Frankfurt. Anycast cannot make that promise because topology does not respect national borders. 4. The second region is a warm standby. Why keep a whole region idle? In an active-passive design, the secondary exists to be ready, not to be busy. DNS failover sends everything to the active region and shifts only when the health check fails. Anycast has no concept of a preferred region, so it would split users across both from day one. 5. Session affinity is required. WebSocket collaboration, checkout flows, and carts in a regional red issue cluster all assume one thing. The user keeps talking to the same place. DNS routing with a sensible time to live plus sticky sessions keeps them pinned. A BGP convergence event mid-session reads to the user as being logged out. 6. Databases are regional and unreplicated. 6 single region primary or a cache with no cross-region replication means the data has exactly one home. Route a user to the wrong region and every query crosses a wide area link. That adds 50 to 150 milliseconds multiplied by every query on the page. 7. Weighted rollouts are part of the process. Shifting traffic from an old stack to a new one in stages needs percentages you control. Route 53 weighted records, Traffic Manager weighted endpoints, and Cloud DNS weighted round robin all express that directly. BGP has no vocabulary for send 25% there. 8. Latency routing needs explicit health checks. Route 53 latency-based routing measures real observed latency between resolver networks and regions. Each query goes to the fastest healthy option. You keep health check thresholds, custom time to live values, and per resolver overrides. 9. You are standardized on one cloud. Route 53 wires straight into load balancer health checks and CloudWatch alarms. Traffic Manager ties into Azure Monitor and Cloud DNS into Cloud Monitoring. An independent Anycast footprint means a second control plane and a second on-call runbook. 10. Fine-grained routing control is preferred. Draining a region by dialing weights to 0 is ordinary DNS policy work. Those multi-condition rules are the difference between a planned maintenance window and an incident. Anycast gives you no place to put that logic. Sweet spot in hybrid reality. To sum up, this is rarely an exclusive choice. The strongest architectures use each mechanism where it is naturally good. Anycast belongs at the edge, handling geographic distribution and attack absorption with nothing to configure per region. Explicit DNS policy belongs behind it, pointing at regional origins with health checks. Where residency rules apply, geolocation routing is the outermost constraint. Compliance is a hard boundary, and performance is an optimization inside it. A WS Global Accelerator gives you Anycast entry points in front of regional endpoints you still control. Whatever you choose, measure latency from real users rather than trusting the topology diagram. The nearest region and the fastest path disagree more often than anyone expects. Thanks for checking this out. Hope you learned something. Find a lot more articles and guides on both systemsarchitect.io and codeguides.io.